Hi, good morning and good afternoon to everyone. My name is Ronan Keane with OpenLegacy, and I want to welcome you to today's webinar titled Cracking the Legacy Integration Dilemma, 5 Easy Steps to Get Started. We've also included a hashtag here so you can follow along on Twitter. It's hashtag OpenLegacy. And our agenda for today is rethinking digital transformation, steps to incorporate your on-prem systems, test and deployment strategies, real-life samples, DevOps-driven transformation. We're also going to have a demo at the end, so please hang around for that. And then finally, we'll end with questions and answers. But before we start, I did want to just ask everyone to pay attention to a couple of housekeeping issues that we have. So we are going to be recording this webinar, and there will be an on-demand link emailed to you within 24 hours. I'm also very pleased to say that attendees will receive a free white paper titled 5 Ways to Quick Start a Digital Transformation Project for Your Legacy System. As I mentioned, we will have questions, and to submit your questions, just use the questions widget in the Zoom webinar window, and we will answer those questions at the end. So let me introduce our two speakers. We have Marty Bacall, our Product Marketing Director, as well as Zev Avidan, our Chief Product Officer. So how do we get started? When we speak to all of our clients and our future clients, one of the major questions and issues that arise is how do we start our digital transformation? There are so many initiatives that we as a business want to start, but we just don't know where to begin. And with OpenLegacy, we promise you that you can start off easy and grow at your own pace. And that's exactly what we're going to show you in this webinar. So I want to hand it over to Zev Avidan to begin. Thanks, Zev.
Thanks, Ron. Thank you, Ron. So let's start by talking about legacy integration. So when we're talking about legacy integration, of course, we're talking about integrating to legacy systems. What we don't want to mean, but often do, is legacy integration concepts and ideas. And that's not what we're aiming for. So what we really want to do is to approach that issue and challenge with a modern approach. And a modern approach, of course, starts with concepts like new digital environments, cloud, microservices, all of those things we will talk about. But first and foremost, let's talk a little bit about DevOps. Now, the topics that we're going to discuss today, you don't have to already have moved to DevOps in order to understand them or recognize them, but you need to understand that DevOps is kind of a spectrum. So it's basically a series of methodologies and practices that helps you automate what you're building, deploying, testing, and releasing. And basically, DevOps main concerns are about two things: quick releases, meaning the ability to deploy at velocity, and testing. That's a big issue and big challenge. Of course, there are other things as well, but DevOps is basically kind of the idea of having the same people, the same team, the same processes for the development and operations, so that they are kind of merged together in order to gain that agility. Now, as DevOps is a spectrum, of course, you will incorporate some of the practices in whatever you do in order to kind of reach a more modern type of integration. That is good in practice, but you also need the tools and the methodologies to allow you to integrate in a way that's modern, that allows you to incorporate your legacy assets into a modern digital environment. And to give you a couple of examples on that, I'll move to Marty.
Thank you very much. So some examples of some enterprises that actually jumped right in and really got started quickly. We had an insurance company that created 100 APIs in 2 months, and it really saved a full year of man hours. This wasn't a company that said, we've been doing this for a while, we're going to keep doing it, and we got to that efficiency. This is one who jumped right in, so we're going to get started. We have to get a bunch of these APIs done, and they started just working on them, and they realized that's how much they did so quickly. We had another bank which actually deployed 27 new APIs, more than 70 microservices part of that in 10 weeks. So we're going to discuss a little more about microservice things like that a little later on, but basically you can see that. And another one that really was also new, created an API in less than an hour compared to 1 or 2 months previously. So the question is, if you can dive right in and follow some steps for diving right in, which we're going to discuss next, you're actually going to do much better and be able to get things done really quickly. So now I'm going to hand it back over to Zev, and he's going to discuss the process in microservices, things like that.
So thanks, Marty. So basically, I mean, as Marty described, I mean, there are already people doing that, but exactly what is it that they're doing? I mean, what's the challenge? So let's describe the challenge a little bit. So most organizations, most large enterprises, they have backend applications, legacy applications, and legacy can be a lot of different things. It can be a mainframe, it can be a mid-range AS400, it can be an SAP, an Oracle application, a SOAP service, XML endpoints, a lot of different things that are not API'd, not on the cloud, and not adhering to modern DevOps principles. All of those things are considered legacy. And really the problem is that if you want to leverage them in a digital environment, then you need to go through some kind of migration or process of changing them, or connecting to them using what traditionally are old integration stacks. And the problem with that is that what you're trying to achieve by digitization, by modernization, by moving to microservices, what you're trying to achieve is really that ability to move really, really quickly. So all the automation that you gain from DevOps and all of those things really suffer if you're, at the end of the day, also connecting to those legacy systems that run really slow. And if a process takes you, just a couple of minutes to create the front end of, but then a full month to create the access to the legacy side, then you're spending a full month on creating that process, and nobody cares about the couple of minutes that you just spent on creating the front end. So really the chain cannot be stronger or quicker than the slowest or weakest link. And that's the problem. But how do you get started with doing that? How do you get started with really modernizing the way you work, modernizing the way you integrate with those legacy systems? So it really is about getting started small and then moving away from that. So I'll let Marty talk about that.
Sure. So we really want to talk about getting started with limited resources. This has become really popular over the years with Agile, with DevOps. They talk about having small teams that work together. But you don't want a member of the team that really is a limited resource already with their own groups. And legacy team members tend to be limited resources in general. In their groups, they have to get certain things done. There's a very small group of them. And so that becomes a pain factor if they have to be part of the team that's doing the integration itself. And why are they normally required? For analysis of the actual legacy system, for data translation, because they're the only ones who know the types of some of the arcane types and things like that that you actually work with, and many times for building facades on the legacy system itself. So the goal is not to require them. They still could be used if they're the right resource at a given time, but we don't want to require them to be part of the integration team. Now I'm going to hand over to Zev, who's going to discuss how that actually works.
So how do you do those kind of practices without introducing the legacy skilled people into those cross-functional teams or into those processes? Of course, there's also great ways of doing DevOps on the legacy side. There are offerings in terms of mainframe DevOps and other legacy systems, and they work well for those legacy systems. But the problem really is how do you integrate, for lack of a better word, how do you integrate the processes from that legacy system all the way to the end result, to the deployment environment? And the surprising answer to that question would be you don't. You don't necessarily have to do that. And the reason you don't necessarily have to do that is because you can abstract those two components or those two parts of the side of the house. So basically, the idea is that if you're able to abstract one team from another, meaning the legacy side, which is not, does not lend itself very easily into DevOps practices, it's not very distributed, it's very centralized. There are system admins and all kinds of these centralized functions. If you hide or abstract that part of the house from the other part of the house that moves in cross-functional teams, that can move very quickly, use different types of technologies, if you can basically decouple and abstract those two different types of processes, then you can gain the agility and the ability to move really quickly without really needing to make a huge effort in terms of changing the way you work on the legacy side. Because the truth is that the legacy side works, otherwise it wouldn't be a legacy. OpenLegacy represents that kind of layer of abstraction, basically allowing you through things like automatically generating Java SDKs for legacy systems, basically creating an abstraction layer that you can pull on from to create modern services, and not needing legacy skills or actually any knowledge in terms of what the legacy looks like in order to create those APIs. The result of that is that you have teams that can move between the cloud and hybrid integration projects. They're cross-functional, they're very agile and nimble, and they can deploy really quickly. And we're talking about deploying, dozens of times a day. We're talking about deploying a dozen APIs per week. These types of results are only possible if you don't need to go to the entire stretch of the runway just to get to a service that gets from the front end, for example, to a legacy system, but you use an abstraction layer to do that. But you need to start somewhere, and usually it's a good idea to start small, start with an MVP. I'll let Marty talk about that.
Sure. So we start with an MVP, minimal viable product, right? Everyone always talks about minimal viable products with lean development, with agile, with many different things. So, but how do you do that? Well, you always talk about skewing the trade-off towards the strategic. You want to pick something that's a real pain point for an organization, that it's impactful to stakeholders and is easily definable. And then you want, but how can you do that on a legacy system is what we're really discussing here today. One way is automatically parsing to simplify that monolithic application that's part of the legacy system. And so the team can pick whatever content they need and work with it very easily, rather than having to go and analyze the whole thing to get somewhere. And this really simplifies the integration scenario and allows teams to get started. We have a customer, iAlone, and iAlone's goal was to not have IT be the bottleneck. And they had this very specific use case, which was like an MVP for them, which was a new deal, a large bank. And they really wanted to be successful at this new bank and start selling to the customers immediately. The agreement was that they could sell their insurance, which it's iAlone insurance, to business customers of the bank itself. So usually what would happen in these scenarios is you'd finally sign the contract and IT would still be working and you'd have a few more months before it actually got started. And that's time lost money-wise, it's an expense to the teams, and it's sort of an embarrassing start in some ways with the bank. In this case, they actually got the software updates completed 2 months before they signed the agreement with the bank while it was still going through all legal and everything else. Now, what solution did they do to do this? They chose DevOps to have fast iterations, to get things done quickly and to work with it. And they needed legacy integration because they have a legacy system back end for it. To dive a little deeper into how iAlone actually achieved this and what tools they use as part of their process, I'm going to hand it back over to Zev.
Sure. So in terms of iAlone Insurance, basically what they figured out is that in order to gain the agility that they needed to create kind of the entire DevOps pipeline from beginning, from requirement management, which they did on Jira. So basically Jira was the place where they introduced the requirements in terms of APIs. Now, modern concepts talk about APIs as complete products, that they have life cycle, they have specs. So basically you treat them as you would treat any other product. So creating a product or starting a product roadmap begins with a requirement management tool like Jira. But from those requirements, very, very easily, they were able to automatically create the SDKs and do the implementation itself using the OpenLegacy platform. The OpenLegacy platform basically automated the process of creating the services from their legacy system, in their case, an S400, and basically creating Java components or a Java code project that encapsulates the entire integration stack for a specific functionality on the legacy side, and also all the cross-cutting concerns and the microservice that's needed. All of that was introduced into Git as a source control. From there on, basically they used Bitbucket and the ICP product by IBM, and the deployment eventually automated into a Docker container on a Kubernetes framework. The automation server in this case was Jenkins. Of course, most of these components are replaceable, so you can have multiple, different types of containerization solutions. You can have different types of container communication solutions. But really, the process here is what's important, because everything from requirement all the way to deployment as a continuous development, continuous deployment really is automated, and that means that you can move really fast. And that's how you go to 200 APIs in a couple of months, and that's how you get to really having the IT not being the constraint of creating those services, but really be constrained by demand, which is what you want to do. You want basically to the business side to set the pace of innovation. And to talk about how you build those connections, I'll let Marty talk.
Sure. So the third step or way we're talking about here is to build connections legacy quickly and easily. In many cases, you'd say this might look daunting. You have to design the API, you have to build the facade on the legacy system, you have to streamline the communications to make everything work, especially for speed and for everything else as you start to do it. And then you have to retrofit the deployment environment. That means actually figure out a way to deploy on the cloud system something maybe came from the legacy system, and build on proprietary processes, because many cases that's how the communication works. And there's just a lot of different steps there. Now, how does OpenLegacy make this much faster, much easier? We automate that whole process. We just expose the APIs. We don't require you to build a facade. We generate the connecting code directly, and it's a direct connection, which makes the execution really quick. So we're really talking about here the legacy system. We fetch the information into our IDE. We then parse it and get some data about that information. So we can allow you to build the IDEs and the SDKs with all the data actually connect back, and any orchestration you need to do. We generate out the microservice with all that information, and then we can deploy that, whether it's on the cloud or whether it's on an on-prem system, because it's all done through containers and through different information. So building the connection to legacy quickly and easily is a feature, and enables you to build an MVP quickly and get results quickly, just like iAlone, which we talked about earlier. Now I'm going to pass it over to Zev for automatic test generation.
So what Marty basically described is how do we create those services. So you can think about it in two ways. You can think about it tactically or strategically. So tactically would be I have a need for a couple of APIs and I will create them as I need. You can think about it strategically, meaning I will create the entire abstraction layer, and then whenever I need your services, I already have them kind of abstracted. But having said that, this abstraction layer, you need to make sure and that it's working, that you test it periodically, nightly test and all those things, but also throughout your progress of developing it. And that's where really test generation, automatic test generation becomes really important, because as you go along, you want to move to a test-driven design. Test-driven design means that you can test everything while you develop, and every little module, every part of the process can be tested separately. And the way you do that is basically by creating testing modules for the different components. So in this case, the abstraction layer is basically comprised out of two main components. One component is the SDK. The SDK, that's, as you might remember, it's the Java object that takes care of the entire integration to a specific functionality. That one Java object that just populates from the legacy, that can be a testable unit by itself. So indeed, it is created with a JUnit testing module. You can test it. You can see that you're indeed getting the data that you expect from the legacy side, but that's not an API yet. The API is a different part of the project or implementation, and that's where you introduce that SDK as a dependency, and you add cross-cutting concerns such as analytics and security and other stuff, but also additional business logic, because you might not want to expose the service from the legacy side as is. That business logic can be further tested. So you can test the SDKs, you can test the APIs, and you can test the entire thing altogether. You can use JUnit as your testing module. You can use Swagger in order to run the API and see. You can use the facilities that are allowed to you when you're deploying to a Docker environment for logging and information like that. But the most important thing is that you're not really testing integration. And that's a really important distinction. Testing integration can be really hard because you have proprietary tools and you have different layers and different products. In this case, you're just testing Java code. And testing Java code, that's something that's pretty simple. You already probably know how to do that. And there are a lot of best practices around, a lot of tools and utilities around. So basically, by moving the problem from an integration domain into code generation domain, basically you gain all the benefits of being able to automate the testing, automate the test module generation, and really move it to more of an application development process that's easier to do and easier to solve for. But then, of course, after you test it and everything works great, now you need to deploy it. And I'll let Marty describe the deployment process.
So in some ways, thank you, Zev. In some ways, the deployment, which is our fifth step here, is we really simplify the deployment. Why? Because microservice architecture are really easy to deploy inside of containers. And they're really self-contained units with an interface, which is your API, and connections to whatever you need to go to, and very self-contained, which makes them really easy to put in the cloud or on a legacy system, however you want to do it, an on-prem system. So the microservices ease the deployment. We automatically generate for you the Docker with the bindings, and we can even configure a gateway, or you can use your own gateway. It's up to you. And it's a very simplified process overall. And so that's the whole idea, is that the microservices make this easy. Now, some quotes from a few different customers. Credit Corp said, "This simplified our architecture to deploy faster and more efficiently." They said they could deploy so much faster and so much more easily than they ever have. Another one, which from senior architect, said architects have grown accustomed to thinking robustness equals complexity. OpenLegacy really said that this is the other way is true, and they mean that really you don't need robustness. You need some simplicity, and then or complexity to be robust. You need actual simplicity, and then you actually get a nice robust system with nice simple things that are all tested independently. The microservices each can be tested independently, made sure they work, and then integrated together. And that's the whole idea of a microservices architecture. And now I'm going to hand it over to Zev to actually discuss the steps that you go through as part of this.
Sure. So basically, if we're wrapping all of those different points together and to describe a specific process or something that you can actually do using the OpenLegacy platform, the steps looks a bit like that. So you start from a legacy asset, right? The legacy asset might be a transaction on a mainframe, might be a database table, might be a store procedure, might be a SAP BAPI, many other different things like SOAP services, any kind of legacy asset. And that legacy asset needs to be exposed. Of course, it doesn't need to be exposed as is, but it does hide underlying data and process. So in order to expose that, basically the platform consumes metadata about that artifact, and the metadata might be code, copybooks, schemas, whatever, and it is native to that specific legacy platform, and it automatically generates the SDK. And as we described, the SDK is a Java component that has the entire integration stack for that specific functionality within that component. That's a very important distinction, because that's not an integration middleware, that's not an integration product. The SDK is just Java code that connects and populates from a specific business functionality. And of course, what that gives you is granularity and compartmentalization, meaning you can containerize that SDK inside a microservice. And when you're testing it, when you're changing it, where you're making modifications, you're not really afraid of touching anything else because it is completely separated from everything else. That SDK, of course, can be used in any kind of Java project, but more commonly, it will be placed inside a microservice. That microservice can then be created according to spec. So you can use different types of templates and basically create it according to your exact environment. Introduce all the different cross-cutting concerns exactly as to what you would like them to be. And then you can test. You can test the SDK separately, and then you can test the API. Of course, at this point, you can also introduce business logic. And because we're talking about test-driven design, while you're generating the new logic, you can test it while you go along. And that new business logic can be integration logic, it can be channel-specific logic, it can be, just new business logic that creates new functionalities. Take into consideration that unlike traditional integration, where you really didn't want the business logic to move to the integration side, it wasn't best practice, although everybody did it. In this case, because we're talking just about a microservice that exposes a functionality, this is exactly where you want to introduce new business logic, because that's your business process. So you're adding that business logic, you can test it, and then you can very easily deploy it. Deploy it, as Marty just described, is done very easily because these are just Java projects, because these are Java microservices projects. They can be containerized in any kind of container solution. They can be then deployed on-prem or on the cloud. And of course, because they're just Java objects, all of that can be automated using an automation server. And you can use basically any kind of automation process in order to deployment between the environments and basically roll them out. So when you roll them out, of course, you can deal with things like versions, like phasing in services, and all of those different concerns that are relevant to what you're trying to deploy. With that process in place, basically what you have gained is you now have an API factory. You have a way to very rapidly create those APIs. And this process for simple APIs, if you're not changing or adding a lot of business logic, that can be basically creating an API from a legacy system within minutes. Most commonly, you will want to do some modification because it doesn't make sense to expose exactly as is the services from the legacy side. So it will take you, between an hour to maybe a full day to create those APIs. But keep in mind, this is versus spending weeks and months on creating a single digital service. And that's the kind of efficiencies that you get. And if you multiply that by hundreds and maybe thousands of APIs, that can dramatically shave, months and years out of your digital transformation project. But it's not just about generating those APIs quicker to begin with. It's also about now you're able to treat them, as we said, as products that have a life cycle. So you can take into consideration that maintenance becomes easier, change become easier, and you can basically retire them after 18 to 24 months and be comfortable with the fact that now you have this kind of muscle of creating APIs. So the more you create those APIs, the more demand, because now things that you thought were impossible to do, all kinds of initiatives that you thought, well, they might be nice, but they're going to take me, a year and a half to do. Now you can do them in 3 months, and that's opened up a lot of different, business possibilities. Now, we said a lot of things about the platform. We said a lot of things about the methodologies, but, for some, at least for some people, more on the technical level, that's for sure, seeing is better than just hearing about it. So in order for us to see it, and in order to see a demo that demonstrates exactly what we're talking about, I will hand it over to George to showcase a demo. George?
Thank you very much, Seth. I'm going to share my screen right now. Please confirm if you can see my screen right now.
Yes.
Yes.
Okay, great. Thank you. Well, thanks everybody for being here. As Seth was mentioning, the idea here is that I'm going to show you how to land this theory into practice. The goal is to show you how I'm going to create an API, fully executable API ready to go to production from scratch by running just a few OpenLegacy wizards over our platform. The idea is to show you how you can leverage your strategy with OpenLegacy by complying with the steps that Seth and Mari were actually mentioning, which is basically making sure that you get started with limited resources. What is easier than just having a simple IDE development environment to start making your developments with just one single developer? As Seth was mentioning, we created an environment that is going to allow you to build a full API from scratch in minutes. And I'm going to show you how to do that right now. So this is our IDE environment. This is part of the suite of products that OpenLegacy has. And the idea is that we are going to start just running wizards, and each one of the wizards is going to take us to the steps to generate the API. So the first wizard is going to be basically generate the structure of the SDK and define which are going to be the connectors and the connection properties that we're going to use to access our legacy system. Okay, so first I'm going to actually run the generation of the SDK. I'm going to call my SDK as test SDK. And in this case, I'm going to use a connection to the mainframe kicks, and I'm going to convert some COBOL code into an API. As you can see here, I have some options that I can play with. One is I can use a template. Templating is part of the things that you can do with this suite because it allows you to actually generate standards for, let's say, security or any kind of testing compliance that you want to comply with. This is the point where you can actually use some of the templates because the code is going to be generated automatically. So next step is I need to tell which connect. Well, I already tell which connector I'm going to use, but the connection properties is the ones that I'm going to put in here. Just you need to give us obviously access to the core system, to the legacy system, and this is going to allow us actually to generate or create the connection. Okay. And you have to get a reserve port for these purposes. And this is all the thing that I need to basically generate the SDK. Okay. As I mentioned already, as I'm generating the SDK, just choosing the connector, putting the connector properties, running the structure generation is going to create all the SDK. And once I have the SDK, what I need to do is to tell which is the entity that I'm going to convert into a Java understandable mode. In this case, I'm using a very simplistic COBOL copybook, which I'm going to actually copy and bring inside it into my SDK for making this faster and easier. You can do that remotely if you want to do it that way, but to make it easier and faster, I'm just going to copy here my sample copybook. I'm going to click OK, and then I'm going to generate the model from this specific copybook. Okay, just give a name to this one. And as you can see here, I can also generate a test unit from the SDK. So this test unit, as Seb was mentioning as well, is going to allow you to put this into whatever CI/CD strategy you have, any automatic testing tools that you may have already. You can put this JUnit into that and make sure that you're complying with all the testings properly and the quality assurance. Okay. As I click OK here, as you can follow the process, I'm actually right now generating metadata from the entity model, from the entity that I have here. Okay. One important thing here is that I'm right now trying to focus on just one single minimum valuable product. Okay. Since I am just a single developer and I'm just making a conversion of one specific copybook, you can convert a group of copybooks or a group of entities, and then show that you're adding value with one specific product that is going to be not very costly to start with. Okay, so this way you can actually have an SDK, and as you can see here, the SDK has already identified the copybook, has already identified the fields that are inside of that copybook, and the actions that I can take with this specific SDK is to execute this one. And I have the source code that allows me to see what's inside and what is that I am converting. The fields have been converted to Java. So whenever I need to do the conversion to other format, it's not needed to do manually. So you just need to pick and choose to making the mapping. So the mapping is going to be more easy on the following steps, and you're going to see that as well. Okay, because mapping is one of the headaches of building APIs, because you need to understand what's inside of the other side, but you don't need to do that because the parser that we're using has already done that for you. So this is my SDK ready to be deployed, and what I'm going to do is basically deploy to make it an executable jar file. And continuing with the strategy that we are showing, the 5 easy steps, it is important for you to see that we are building connections to the legacy very fast and very easy. The SDK that you just saw how I built, it's all you need to do to have a connection to the legacy system. That is also very important. That is aligned with the strategy that we are telling in this webinar. Okay. Also, as I showed, you're able to create the JUnit during the SDK generation and also during the API generation, and that is going to allow you to automate the testing as well. So we already built the SDK and we already built the model generation. Now I'm going to do the generation of the API, okay, which is running another one of our wizards. I'm going to generate the API. Sorry, test API. And then I can deploy in many ways here. Use a RESTful API standard, use SOAP services, or even custom. I can use a template project as well here to customize your API. And I can also deploy in a full microservices ecosystem. If I click in here, I can choose the 3 most frequent standards on the microservices, which is Docker, PCF, or OpenShift. I'm just going to deploy in RESTful mode right now to make this demo faster. So as I click next, I just need to pick and choose which are going to be my dependencies. I can choose 1 or more dependencies. In this case, just going to do a straightforward process of bringing information from the mainframe. So I'm just going to add the SDK that I just created. Okay. As I click finish, this is going to basically generate the full structure of the API, and this is basically executing this 3rd wizard. And as I mentioned, I already defined the dependencies, in this case, just 1 dependency, and I just created the API structure, okay? So I have my API generated, and what I need to do right now is basically to make sure that I can comply the contract, and because my minimum value product has to be, understandable, and this is when you actually make it take value by generating an API from that SDK. Okay, so I'm gonna put a name to my API to be published, and this is the moment where you actually generate the contract, and as you can see, all the data structure, the entire data structure is there, and all the fields, I can read them very easily and understand. Even you have help to know what's inside of the code here if you want to see it. So I'm going to put a very easy API with just one single input, which is going to be the customer ID, and then I'm going to bring back the entire structure of the data, which is one of the things that you can actually do. So if after this generation, somebody changed the code and they changed the structure of what's inside of the COM area, I'm gonna keep bringing all the information because because every time you run the API, it's gonna bring the latest version of your copybook. So this data that is in here, if it changes, you don't gonna have any affectation, and you don't need to regenerate your API. And that's one of the things that is gonna be very good for you during the generation or maintenance process of the API. So as I click OK, what this is gonna do basically, it's gonna generate the contract. Sorry, I'm moving really fast. It's gonna generate the contract here, and the contract is gonna be also Java code. And as you saw, I can also generate a JUnit from this and take it to the CI/CD DevOps strategy that you have as well. What I'm doing right now is generating an API that is gonna be deployed in a Swagger specification mode. So the only thing I need to do is to execute the API right now, and this is gonna use the test SDK that I created, and as you can see, aligned with the strategy, the 5 steps, you can see we automate the test generation because we can create test units in both of the steps during the SDK generation and during the API generation. But also we are simplifying the deployment because as I showed, you can deploy in a microservices environment, SOAP services, RESTful, whatever standard you want to use. The OpenLegacy suite is going to help you make that deployment faster. Okay, and this is basically, you can automate the deploy. If you deploy in our console, you can use, or you will see and be able to control and manage some analytics and do some optimizations and control some security for the entire microservices environment that we have in our console. Or you can optionally also deploy into an application that we can generate dynamically. The code you will run also a wizard that is going to allow you to generate an Angular code. Okay, so my API is now running and it took the port 8080. The only thing I need to do here is to launch a oh, there it is. Okay, sorry. To launch the way to present this on a browser, and as part of the standards that we have on the templates that we have on our APIs, we have added O2 security, which is the standard for APIs. You need to just comply with the credentials here to authorize access to run your API, and then I can just post it, and then you will see that my API is not showing issues so far, and I can actually try it out and put some real information to make sure that my API is running properly, okay? And if I execute this, you will see also the speed of the response time is very, very good because you're going straight to the mainframe using only the kicks. There's nothing in the middle, and you're bringing actually real data in real time. This is basically all the steps that you need to follow. And as you saw, I just created a fully executable API ready to go to production with all the Java code that you need, and you can take control of that. I'd like to show you also this, which is part of the developments that OpenLegacy has done, which are the editors. You will see very easily all the information about your API by just clicking on these editors: inputs, outputs, backends, mappings, and maybe the most important thing here is that you have access to the code. You have the interface source code, you have the implementation source code, and the controllers as well. So you can actually do things here like do some orchestration or transformation, even put some business logic if you want to put it into your APIs at this point. you can do that as well and relaunch your API, and the process is going to run that way. So this is basically the way we can use all the OpenLegacy suite to help you land this theory into practice and build your APIs in minutes, as I just showed up. So with this, I'm going back to you, Ronan, and I think that's on my side.
Yes, thanks, George. That was a really good demo. Thanks very much. So I know that we got quite a few questions so far. I did want to mention this to you, though, that you don't need a steering committee like in this cartoon. We've tried to make it really easy for you to get started. You can schedule a personalized demo or schedule a proof of concept using either of these two links, and we'll be sure to get those links to you with the webinar video recording. So just really quickly to wrap up and then jump into our Q&A. The most important points here are getting started with limited resources, starting with an MVP and building connections to legacy quickly and easily, automate test generation, and then obviously simplify deployment as George showed you in the demo. So let's jump into our Q&A. We have some questions. I would highly encourage everyone to stick around for the Q&A. You may hear some questions that you didn't anticipate or you might not have thought asking yourself. So we would definitely encourage you to hang around for the Q&A. Our first question is the OpenLegacy SDK only available for Java? Is it available for other languages also? Node.js as an example.
Sure. So in terms of what the OpenLegacy platform supports, so the OpenLegacy platform is a Java platform, but of course, based on the concept of microservices, it doesn't really matter what happens behind the contract of a microservice. So the APIs that those microservices expose can be consumed by anything, a JavaScript, any kind of other language, any kind of mobile, Swift, Objective-C, whatever it is. But the internals of the Java components are Java. If you want to just expose and use the graphic user interfaces George has shown, you don't need to know any Java. If you want to do some more advanced things, more elaborate things, then yeah, some Java knowledge is needed, but this is very basic. So basically, these are just standard Java platforms. So usually would recommend Java people with about 2 years of experience. That's all you need in order to become basically an expert on the platform.
That's great. Thanks, Zev. Next question is, you said legacy people aren't required, so what attributes of people would make up good team members?
Oh, okay. So that's a great question. And I think, that last question was really also relevant to this one. So yeah, so as I said, I mean, Java people, those are basically the people that you would need. I would also talk about some, because these are cross-functional teams, they're doing multiple things within one team. So front-end people usually are, JavaScript people, API people. This is, something that you need to consider. There's a concept called APIX, meaning API experience, which is kind of akin to user experience. You don't have to have a specific person who's, an expert in APIX, but what is important is that you have somebody who knows enough about the business side of how will people consume the API to be able to create an API that's very easy to use, that makes sense on the business side and also on the technical side. So that's an important person to have on the team. In terms of the technical skills needed, those are mostly Java skilled people, DevOps people, and some people with understanding on infrastructure and so on and so forth. So basically, it's just a normal cross-functional team that you would find in any kind of a project. You don't need, or at least you don't necessarily need, any kind of legacy skill people. You don't need COBOL people. You don't need the mainframe system administrators or something like that. You basically just need a normal cross-functional team in order to make it work.
That's great. The next question is the I alone slide didn't have API management listed. Is there a way to do that?
Yeah, absolutely. So as OpenLegacy as a platform, usually we run behind an API management platform. It can be any one of the big ones. It can be a MuleSoft, an APG, WSO2, whatever API management platform out there. But we also do have a component that's basically a Swagger-based API management that you can use. We usually recommend it more for internal APIs because there are some features that are more geared toward the external APIs. Which we don't, that's not our main focus. But once you choose an API platform, we're very easily integrating into whatever it is that you're already using or planning to use.
I guess one more quick question on that, Zev, from my thoughts. I mean, they're also using Kubernetes for some of their orchestration and things like that, that some of the API management companies do. So some of the reason why I alone doesn't stress as much on the API management is because they've deployed their microservices with Kubernetes doing some of the orchestration and some of the other things you do. It doesn't do everything an API management company does, but that's some trend some companies actually are doing when they go strictly to microservices. But that doesn't mean we don't work very well with the API management companies. Just, that's a decision they made. And we try to give them flexibility.
Definitely, and thank you, Mari, for that point, because that's actually a very interesting point with regards to orchestration versus choreography. If you think about API management, there's a lot that can be said about the security parts of it, the high availability, and setting those things. In terms of orchestration, really, you can think about not so much about orchestration like an old DSP type of orchestration, but rather this allows you to move to a choreography model where you can basically orchestrate without an orchestrator. So basically, you don't have a workflow, you just have different services that are using one another, and that's why you don't need that part of an API management platform, or you can use basically an API gateway, a modern one, and not go through an old type ESB in order to do that. So thanks, Marty. That's a very important point.
Great. Thanks, Evan, Marty. Next question. You talked about testing. Do you also help with security?
Yeah, so absolutely. So in terms of, we're not a security product per se, but of course, in the process of creating APIs and microservices, there's also all kinds of security considerations. And the way we help with security is basically threefold. So first of all, by automatically generating code, that means that you can introduce into the templates all the different standards and site-specific things that you want to do in terms of security. So we had customers introducing two-factor authentication into their APIs. We have other customers introducing JWT tokens. But basically, whatever type of implementation, of security implementation you want to introduce, that can be templated into the microservices. And of course, we would provide you with some defaults and some best practices of our own. So that's one level of security. A second level of security would be around the fact that these are Java objects, so these are strong type. One of the challenges of moving from SOAP services, XML-based services, to a modern JSON REST interface is that you're moving from strong types into loose types. Basically, you only have strings and numbers behind the scenes. Of course, you can, at runtime, you can check and validate and do those kind of things, but runtime validation will always be weaker than just strong typing it and compiling something with the right data types. Because the data model here is Java-based, then you gain the extra security of having kind of a hardened data model that basically blocks any kind of vulnerabilities with regard to those kinds of possible attacks. So that's the second aspect. The third aspect is, of course, as I said, OpenLegacy is not an API gateway, but we do provide capabilities around managing those SDKs and APIs and microservices, and that includes security. So things like tokenization, things like two-factor, OAuth2 authentication, and of course SLAs with regards to number of and volume of hits possible on an API per specific different client. So these are three levels of security that are provided with the platform. Of course, that being said, we're not a security product per se, but we help you standardize and introduce the security aspect that you need in those projects and services.
And you And you brought up a really interesting point about templates. Templates are one of the real powerful features of our tool because they allow you to sort of change your automation of how you generate your code and many different things that you actually do and build standards for follow the standards of the company or anything you want to do along those lines. That's something we didn't touch on as much in this webinar because this webinar was about how to simply get started rather than talking about sort of the deeper depths, but that's something that's a key feature in our product and OpenLegacy in general that I think is something that we cover in other webinars, other times in discussions.
Okay, thanks, Marty, and thanks, Seb. So what, next question, what are some examples that show how quickly you can build connections to legacy systems?
So, I mean, in terms of just examples, I could give you some. It's not just about, talking about the specific connection that you're trying to create, but it's a more of a kind of overall team efficiency kind of a thing. Of course, in terms of just being able to create a connection, as you saw, within minutes, you can create those connections. But in a real-time environment, we can, for example, an example for a very large tier 1 bank, they had a 30-month project plan just to create the API factory with all the different concerns, all the different teams, and all the different aspects of basically creating a huge project to allow them to build that factory to start churning away those APIs. So that was 30 months that they were planning, and they were not very happy with that. That's where they engaged with us. And basically, on the platform, they were able to, within 6 months, to actually create the API factory to the effect that they were able to deploy around a dozen APIs per week. Another example would be a large telco that basically planned a large API or APIfication project, creating all of those services to be consumed by all of their new digital channels and really kind of bringing everything to a modern digitized environment. And again, in this case, they were able to cut 1.5 years out of the project just by introducing the OpenLegacy platform and automating a lot of that effort. In this case, it was coming from a Tuxedo backend. Another example would be, the Ialon example, where basically within 5 months, 200 APIs were created alongside the entire DevOps pipeline. So actually the APIs themselves were created within a couple of months, but the 5 months was to create the entire infrastructure and the pipeline and everything that's needed. So really, these are dramatic impacts in terms of how much you can cut out of those integration projects, digital transformation project. And the impact is really a dramatic, not just in terms of the immediate impact, meaning you're able to do that very quickly, but also the long term, because by this time, most organizations really understand that APIs are products, API have life cycle, and you should probably calculate around 20% of your APIs each year will need to be rewritten, between 20 to 30%. That's kind of the estimate. So it really is about the ongoing continuous delivery of those services.
And I guess only one thing I'll quickly add is we have a whole number of case studies up on our website, which you can take a look at. And they're in a number of different industries. We also have some of our data sheets that sort of describe how to do it with IMS versus sort of AS400 and all the different ones. They get into some specifics with some of the different platforms, including SAP. So it's a good thing that there's a lot of those great examples that are all up there and available.
Okay, thanks, Marty. So a couple of people have asked this question, and I'm going to answer it. How do I schedule a customized demo for my team? I will say that anyone, the few people who have asked about a customized demo, we will definitely follow up with you individually. But I did want to I did want to go over the demos and the proof of concept fairly quickly, but give you some idea as to each one. So our personalized demo is where we take your data and our assets and actually give you a demo. There's a little bit of upfront effort that needs to be put into it, but it's fairly quick and easy, and we're very glad to do it. You can also just have a demo, not unlike the one that George gave you, based upon specific needs that you might have. So the demo is a very good option to get a good flavor of what you can do. We also provide a proof of concept, which is a little bit, has more meat on the bones, so to speak, where we actually go on site and we will, again, take data and other assets, and we can build APIs for you. And we usually blow people away because they see just how quick it can be done with OpenLegacy. So we encourage you to definitely explore both options depending on where you are. But please follow up with us. And the folks who asked that question on this webinar, I'll follow up with each individual after the webinar. Okay, so our next question is, what makes the architecture simplified compared to anything else?
So the answer for that is really quite simple, as exactly as the architecture is. So basically imagine an integration stack without any kind of middleware, without any kind of layers in between. Basically just a microservice talking directly with the legacy system in a native protocol. That's basically what you're getting, and you're getting that with the ability to do that on scale because it's automatically generated and you're not making any changes on the legacy side. And so that really is the most basic, simple architecture that you can ever have. But it is also the most robust and more performant architecture you can ever have, because there are a lot less parts that can fail, a lot less technologies, and a lot less people involved. So there's less room for mistake, especially if you automate everything. So basically, it's a very, very simplified architecture, but it is an extremely powerful architecture because of the code generation. We do talk with every legacy system with its own kind of native protocol. These will be JCO for SAP or COM area for Kix, and for people who recognize those different legacy systems, these names will probably ring familiar. But basically, these are the lowest level protocols that we talk. So that's as simple as you can get, just a microservice talking directly with the legacy system, no middleware, no additional layers, no queuing, no MQs, no nothing like that. And that's basically the most straightforward way you can do that.
It's great. Thanks, Seb. Next question. Please go over the options for the demo or POC you showed before, but it went very fast. So I think I answered that question. Again, love that folks are very interested in a demo or proof of concept. We're very glad to accommodate everyone, and you'll see the links to those to each web page to make a request. Those links will also go out separately via the email that we're going to send with the webinar recording. And as I mentioned, we will definitely follow up with the people on the webinar who have requested demos as well as proof of concepts. So I believe that is the last question. I want to make sure there are no other questions before we end. Yep, that looks like those are all the questions. So, so ladies and gentlemen, thank you very much for joining. It's been our pleasure to give you the demo as well as show you how to quickly and easily get started with all and any of your digital transformation initiatives. And as I said, we'll follow up with the folks who are requesting a demo. And please look out for the webinar recording, your free white paper, as well as links to the personalized demo and proof of concept. So thanks very much.